Hey, what's up, y'all? Welcome back to another processing tutorial, this one on writing classes. The version of processing that we've been using is built on Java, and Java is an object-oriented programming language, which means that we can write classes to create and control objects in our sketch. A class is basically just kind of like a blueprint that describes all the characteristics and behavior that an object has and can do. And so for today, what we're going to do is kind of create a sketch that simulates like a body of water, like the surface of a body of water during, sort of a downpour of rain. So we're going to make a ripple object so that we can have a sketch that kind of behaves like this, where we click on the screen and we get a ripple appears where we click and then slowly kind of grows and fades out. So it's going to look something like this. Okay, so let's go ahead and make a new sketch, get it set up here like so, and head over to pen and paper to kind of take a look at the syntax for writing a class, right? So to make a class in processing, all we need to do is write the word class. We need to give it a name, and generally you're going to capitalize the name of your class. And then from there, all you have to do is open a curly bracket and close a curly bracket, right? And inside of all your classes, you're going to have three sections of code, right? And the first one is data, right? So you're going to have some data, some variables that your object can use or possess, and you're also going to have a constructor. And this is sort of like the setup loop for your object, right? So when you make one of your objects in the sketch, it's going to run the constructor code that one time when that object is constructed. And then you're going to have a section where you've got some methods, right? And methods are just functions that you'll write that can, either return things for your object, or it can just kind of execute actions. It's kind of like a draw loop of the object, right? So this code can run as many times as you tell the program to run it once the object has been constructed, right? So let's go back to processing and take a look at how we're going to implement that in the code. Let's make our size here 640 by 480, and we'll make our background black this time. And it's totally fine syntax-wise to write a class after. And we're going to make a ripple, right? So we'll say ripple. It's totally fine to put your class here just after all of your main setup and draw functions. You could even have your, we'll need a mouse pressed later, right? Like you can put it here after all of these functions, but it's also fairly typical to create a new tab in the processing IDE, and we're going to name this one RIPPLE, Ripple, right? And we're going to put the class in there. And that's just a way of kind of organizing the code and keeping things a little bit more neat looking and organized visually. So let's go into here and look at all of the three sections. So like I said, we need to have a section for our data. We're going to need to have the constructor, and then we're going to need to have our methods, right? So this ripple, right, we know that we're going to need to know where it goes, and it's basically, we're just making a very simple shape to ripple. It's just going to be a circle, right? So we know that we're going to need like a diameter, right, to define the size of that circle. So let's go ahead and add a couple of variables that we can use that this object possesses that we can use in it. So let's make a p vector, and we'll call it position, or POS, pause, and then we'll make a float and we'll call it d for diameter. In the constructor, all we have to do is just write the name of the object, open and close parentheses, and open and closed curly brackets, right? So this is the constructor here. And then in methods, like let's start with a display function so that we can ask our object to actually display itself or to show something to the screen. There are a couple very common methods people will write update and display, right? Some people will also kind of combine these two and maybe write a method called run that has both of the elements, the updating and the displaying code in the same method. But for us, we're going to keep them separate just so that we can kind of stay organized and have an easier time looking at what's going on. So inside of our constructor, let's go ahead and we'll just kind of populate these variables, right, that we made for the object with some dummy data here. So let's say position equals new p vector, and let's put it in the middle. So we'll say width divided by 2, height divided by 2, the middle of the screen here. And then let's make the diameter of our ripple, we'll say that's equal to the height of the screen divided by 4. Okay, and then in display, right, we are going to say push matrix, pop matrix. Probably also going to want to say, let's see, translate to position.x, position.y, and then let's draw an ellipse here around the origin, and we're going to make it the size of the diameter, right? And the background is black, so let's make stroke white, and we'll say no fill. Okay, so this is our display function method, I guess in this case, is our display method. We've got our constructor that initializes the position and the diameter of our ripple object here, and these are the two pieces of data that we're using. So now that we've written this class, we can go back to our main sketch here, and we can actually add a variable of type ripple, right? Because we've created this class which now allows us to make objects of this variable type, right? So I can say ripple, and maybe I'll name it R. And then here in setup, I can say R equals new, and then ripple, the constructor, right? So you can see this is the same as this, right? So this constructor, we're calling our constructor here when we say new and then type the constructor like this. And then I can go into my draw function and I can call my methods on this object. So I can say r dot display, open close parentheses, punctuate with a semicolon. So let's see what we got. Let's run our code and see how things are looking so far. Okay, awesome. I think I might have mistyped, yes, this. Okay, so now I've created one object, one instance of this object. Now that we've got it in our sketch, right, let's go back and take a look at how we might program our update function so that this little circle here actually behaves a little bit more like a ripple, right? So what we'll do is we'll say D++ maybe. So we're going to make this ellipse grow over time, right? Because we're going to put this update code here. We're going to say r.update. So every time we run through draw, we're taking this object r that we've created here and instantiated here, and we are running the update method, and then we're running the display method, right? And so in update, we're going to update this diameter. Let's see what happens. Okay, so now we have a ripple that's kind of growing over time. All right, so let's look at how we can make this look a little bit better and maybe behave a little bit more predictably. So the next thing I want to show y'all is this function that processing has called millis, right? So millis returns the number of milliseconds that have passed since you hit the run button and started your application, started your program, run your sketch, right? So let's say I hit my run button, right? And then 1,000 milliseconds go by, right? And then I make a call to millis and I say, maybe I might say like print line millis, like this, right? That's going to return 1,000, right? And if 10 seconds have gone by and it's 10,000 milliseconds, right, then it's going to return 10,000, right? So you can kind of see where this is going. And what we're going to do is we are going to use a series of 3 variables to kind of control the birthday, the birth time of our object, the age of our object, and the lifespan of our object, right? And what we're going to do is we're going to say birth, right? We're going to put this inside of our constructor, and that means when the object is instantiated, we are going to set that equal to the current time, basically, right? The number of milliseconds that have passed. And then we're going to initialize age as 0, and then we're going to give it some kind of lifespan. So we may say, I want this object to live for, 2 seconds. So I'll say 2,000 milliseconds, or yeah. And then to calculate our age, we're going to do this inside of our update function, right? But all we have to do now is take millis, right, which is the current time in our sketch, and subtract the birth time from that, right? And that will give us the age of the object, right? So think about it this way, like if my ripple is born at 1,000 milliseconds, right? And then another 1,000 milliseconds pass, then millis is going to return 2,000, right? So 2,000 minus 1,000 equals 1,000. And that makes sense, right? Because if our object has been alive for 1,000 milliseconds, or if it's been on screen for 1,000 milliseconds, then its age would be 1 second, right? So let's go ahead and look at how we're going to put this into our code. Oh, I guess actually, before I get ahead of myself here, the reason we're doing this now, right, is because age will now go between 0 and lifespan, right? So we know that age is now going to have like a predictable value, and just like we were using like the counter variables I or j inside of our for loops, right, to drive map functions, we can do the same thing with our age now inside of our object. So let's go back to the code for real this time and make a few more variables. We'll say int birth, age, and lifespan, right? And here in the constructor, we can say birth is equal to millis, right? Age obviously is going to start at 0. And then lifespan, just for now, let's make it equal to 2,000. So that's 2 seconds, right? 2,000 milliseconds. Then in update, what we can do is we can say age equals millis minus birth, right? Millis minus birth, right? And then we can say if age is less than lifespan, do the thing, right? And we can also now use the actual map function. What we're going to do is instead of just incrementing the diameter by 1 every time this update function is called, what we're going to do is actually map the age of our object, which we know goes between 0 and lifespan, between, I guess actually, I mean, we could make it between 0 and then some diameter, right? So d, right? And let's see what that does for us. Oh, sorry. D equals height divided by 4. Let's try that again. Okay, so now this is going to grow from 0 to the diameter here that we've defined earlier, which actually we could just initialize it as 0 since we're going to start from 0, right? So it's going to start from 0 and go to whatever value we put here. And it's going to do that predictably over the lifespan that we've defined here, right? If I wanted this to take longer, I could put 4,000 for 4 seconds. You can see this just takes a little bit longer, right? Okay, let's go back to 2000 for now, and let's also take a look at how we might make this ripple kind of fade out as it approaches the end of its lifespan. What we can do is we can, here in our display, we can say stroke alpha, right? So we need to create a variable that's going to contain our alpha amount, right? And that's just the transparency of a color. And so this is another way you can take a grayscale value and make it have some kind of transparency value. And so what we'll do is we'll initialize alpha as 255, right? And we want it to start where it's totally visible. And as it grows larger, we want it to eventually have an alpha value of 0, right? Transparency of 0. So you won't be able to, you'll be able to see totally through it. So what we can do in here is we can map alpha, right, to the age, which goes between 0 and lifespan, between 255 and 0. Nice. Okay, and so this is looking a little bit more convincing. Um, Looking a little bit more like a ripple on a pond. Okay, great. So let's look now at how we might pass in some variables to our objects when we create them, right? So one of the things I might want to do with the mouse, like we were doing earlier, right, is pass in the position, right? And so what I might do is in my constructor, I'm going to say, hey, I'm looking for a couple of floating point numbers, an x and a y, right? And in this constructor now, the constructor is now expecting 2 arguments, right? So if I go over here, you'll see I have an error in my code here, right? Because the constructor ripple with no arguments, right, does not exist because now this constructor is expecting 2 arguments, right? And what I can do is I can say, instead of setting these values like that, I can say position equals new p vector float x and y that I'm getting here from the constructor, right? And then this position p vector will be comprised of those 2 variables, right? Okay, so now we can set the position of our ripple object, right, by passing in a couple of arguments here. And what's nice about that is now I can make a couple of ripple objects, right? And then I could come in here and I could say R2 equals new ripple. And this one I want to be at width divided by 3, height divided by 3. So I'm going to have one over here and one over here. And then, of course, I'll need to run the update and display methods on this second instance of the object, ripple object that I've created. Cool, and now you can see I've got 2 ripples that just appear on the screen from the very beginning of the sketch. So you can see once you've got your class, you can start to create variables to contain the objects from that class, and then you can instantiate them, and you can also run the methods on them in your sketch. But you can imagine, like, well, if it was really raining, there'd probably be at least like hundreds of ripples like going all the time, right? And I don't really want to have to type this code 100 times. That's not the best way to do this, right? So what I'm going to do instead is use what's called an array list. It's very similar to an array, which we covered in a previous video, but the syntax is a little bit different. And it's also different from arrays because you can change the size of an array list after it's been created, right? Which an array is of a fixed length. And array lists allow you to add and subtract things from the array list while the sketch is actually running, while the program's running. So let's get rid of this code for a moment and look at how we can use an array list. So we'll say array list, and we're going to tell this array list that it's going to be containing objects that are of type ripple, and we can name this list ripples, and we'll set it equal to a new array list with ripple objects in it like so. So now I've got an empty list of with nothing in it, but that it can contain ripple objects, right? So now if I want to add something to the list, whenever we're going to do it when we click our mouse, right? Now I can come in here to mouse press and say ripples.add new ripple, right? And this will be at mouse X, mouse Y. Okay. So now what's going to happen is whenever, oh, sorry. I also have to put some code in here to actually grab the things from the array and run the methods on them. So what I need to do here is I need to use a for loop, and we're going to use the basic syntax. There's a fancier way of writing this, but just so that we keep it simple for this video, we're going to just say int I equals 0 if I is less than ripples dot size, right? I plus plus. So this for loop is going to run for the number, it's going to iterate for basically the number of times as there are objects on this list. So when we first start our sketch, nothing's going to happen, right? This is going to run 0 times because this will be an empty list. But every time we add something to the list, this number gets bigger, right? 1 object gets added, 2 objects are there, 3 or 4 objects, whatever, however many times I click, right? And so then this for loop will start to iterate more than 0 times, right? And so inside of this, what we're going to do is we're going to say ripple r equals ripples.get I, right? And so we are going to create a little ripple object for us to use, right? And every time we iterate through this loop, and we're going to grab the object from the list based on whatever number of iteration we are in this for loop, right? So then, now that I've got this little variable, this object variable, I can then run the methods on it. I can say r.update and r.display, right? Okay, and so now, and wherever I click my mouse, got my ripples. There's one other thing I want to kind of warn y'all about, and that is that as the list gets fuller and fuller and fuller, these objects never actually go away, right? And we don't really want to kind of have this list full of objects that we can't see anymore or that aren't really doing anything anymore. So what we can do is we can say, we'll add another for loop here. We'll say for int I equals 0, I is less than ripples.size, I plus plus, and then we can say ripple r equals ripples dot get I. So the same code as we did before, right? Just creating a little ripple object for us to run methods on. What we can do is we can say if r dot age is greater than or equal to r dot lifespan, right? So if this age variable is equal to or greater than the lifespan that we've defined here for the ripple, what we're going to do is simply ripples dot remove that object, remove it from the list, right? And let me just do a couple things here for us. Let's say print line ripples dot size, right? Just so we can see that as we click around the screen and add ripples to our sketch, this list is going to grow, you know, every single time I click the mouse. If I click it a bunch, just keeps growing and growing and growing, and you can see the performance gets worse. Every single time I add another ripple, just because now the program has so many more things to worry about. And also, right, the alpha value, as these kind of stack up, right, you end up being able to kind of see this ripple. So what we want to do is actually remove that object from the array list anytime it meets whatever condition for deletion that we've defined here. And then we can just print line the size of our array list here, so y'all can see how that works. So now if I click around the screen, right, I'm adding objects to the list, and whenever these ripples get to their maximum size and they fade out all the way, then we just take them off the list. Beautiful. Okay, so that's going to help with performance, especially when you get into making more advanced sketches. Let's just do a couple other things here. This is basically the sketch, right? There's a couple other things I think I had in the example code that kind of make it look a little bit prettier and behave a little bit more organically, if you want to think about it that way. So we're going to add some generativity into our object here. So let's make it so that, first of all, the lifespan is going to be different for each object. We're going to say random 2000 and 3000. So this lifespan is going to be somewhere in between 2000 and 3000. And then let's make it so that they are not always all going to be the same size, right? So I might say something like max D, max diameter, right? Initial diameter is equal to 0. And the maximum diameter is going to be equal to random. Let's make this the smallest that it could be. And let's make height divided by 2 the largest it could be. And then we're going to, instead of mapping it between 0 and this hard-coded value, we'll say between 0 and max diameter. Okay. So let's run the sketch and see what we get here. Yeah, and this is something that looks a little bit more organic. You know, each raindrop might be a different size, and you know, it may create a larger or a smaller ripple, right? So this is getting us kind of closer to actually simulating like the surface of a body of water here. I guess what else did I do? This was kind of fun. If we haven't seen this yet, you can also change the way the cursor looks. And this was, I guess, this was actually kind of reminding me more a little bit of like an old school video game, like a Missile Command or whatever it's called. But this can be kind of fun. So you can make the cursor inside of processing a cross instead of a regular pointer, and that can be kind of fun. All right, so you know, like I said, there's a lot more that you can do with this. You could start to change the background to blue, and you could make the ripples be like different shades of blue. You know, you can kind of get creative with how this looks, but this, I think, is as far as we're going to take this particular sketch, just to kind of get y'all started with writing classes to create and control objects in your sketches. I'll see you all in the next video.